Hello everyone, welcome back. Today's topic is scatter plot, compares between the runtimes and versus IMDb score. I'm going to give you a chance to break down to the purpose of this code with this. You must know that pandas data frames or you have the PySpark data frame. So I have a PySpark frame. Here's the detail for beginner-friendly explanation each step in your Python code. First is initial setup OS, utility for interacting with the operating system, and pandas, the library, is the library for data manipulation and analyst. The third one is seaboard, is for data visualization library based on the matplot library and providing attractive post-matplotlib library and a pyplot based plotting library. That is a plot library. The final utility is for displaying image inline in data nodes as the IPythons and display library as an initial setup. So I'm going to click run cell. There's nothing error in this moment. And step one is to read the file with this beautiful code. I'm using the Spark, the read format CSV. And then there are several options and finally root. This is file location. So Spark read format CSV is to read a CSV file into Spark data frames. Info scheme, where the false option is header separated, is the option to specify not to import schema. No headers in CSV, and that's columns are separated by comma. Final load, when the file location is to load the CSV from the specified file location that we have this declaration that we have been used. Second step is get columns name. So this is going to returning the first row as a class, retrieving the first row as a row object. Second is the column names by extracting the column names from the first row to a string. So after the retrieving the first row, we're using the cell to convert each cell to a string and call names columns names. Since we had applied the step 2, step 3 is remove the first row. What it does is to filters out the first row from the data frames PySpark. And then step 4 is assign real column names. I'm going to assign the real columns from the original data frames by using TDF2DF, this column names with arguments, is to rename the columns of data frames no header using this. Step 5 is just column first lines in this code is to define the variables storing the columns names for runtime and IMDb score and type. A simple N is the number of the samples to use for plotting. So how many samples that I take it out to display for plotting. Step 6 is sample and convert to pandas. I'm going to check and convert from this line in string. The type is data frame with columns that we have defined. It is to determine if the data frame is Spark date frame? And if yes, it is for the selecting. It selected specified columns, limits, row to sample and the object and convert to the pandas using toPandas library or method or something else. If it is already a pandas data frame, is create a simple directly. Step 7 is normalized type column. I'm going to copy this. It's kind of definitions in Python code. The name is normalized type functions that I created is to convert value to uppercase and standardize the types to movie or show or other. So I'm going to normalize the type, the column, each row, and then pre-applied the normalized type. It is to apply this function to the whole and the columns and that's data frame. Step 8 is I'm going to convert to the numeric. Since we have the PDF, runtime under the columns, IMDb columns, I'm going to assign each line to the numeric. This is to convert columns and coursing errors to none. So step 9 is filters data. So this is a drop now is to remove the rows with none in specified columns. So it is to see the user guide like this. There is a parameter, a signature, definition drama is access, how to do this to remove missing value and see the example, parameter access, and how and trash and subset in place. This is going to return data frame or none. See all this is values. Example this with data frames in Panda. It's draw to columns where at least one element is missing. So this is for the removing the rows with none in specific columns. And then after that, the filters is to retain rows with IMDb scores under 20 and positive runtimes, and type is movie or show. This is not returned to the other after we normalize type. So step 10 is to plot the data we have filtered. This is the Python code. We're using the plot and to set up the figure size for the plot. The size is 8 and 6. Since we imported the seaborn is used to create a scatter plot using seaborn. The with data equal PDF, X runtimes, columns is defines X and Y axis, and this color is to color points based on the types catalogs, move and movies and show. The title is going like this, X, Y level. Is set the colors, the palettes, the transparency of the cool. And after that is title is to add the plot title and relation between the runtime and IMDb score. And with X level and Y level is level for X and Y axis. After using the X and Y level and title, it's time to add grid line for better readability. And the tight layout to adjust the plot layout to prevent overlap. So to the final display, the plot, the show, is to display the plot in the output. So I'm going to click the run. The output is showing, going like this after the fetching result. Isn't it beautiful? Okay, based on the scatter plots provided, here's an analysis of the relationship between the runtime, minutes, and IMDb score, like point, for Netflix content. In the general observations, there is a separations by types, like show and movie. Show is shorter run times than movie time, right? So it is mostly under 50 minutes with a wide range of IMDb score, approximately 4 and 9, correct? How about the movie? Movies range like all from the 0 to 910. Is all scattered like in a center, at the center. Is longer run times, extending up to 2 and beyond 200 minutes, with scores generally concentrated between 4 and 8. Correct? What about runtime and IMDb score relationship? For show, is all runtimes. Its runtime are clusters on the 50 minutes, and suggesting these are likely episodes of TV shows. Despite the shorter format, the high score are recorded, indicating the quality or viewer appreciations is not solely dependent on the length. For movies, is a broad spread of the runtime, where the most movies between 70 and 150 minutes. Correct? Here. For movies, a broad spread of runtime with mostly between 70 and 150 minutes, and is a slight concentrations of score around 6 to 8 or 5, indicating a generally favorable receptions for movies in this range. And it is few extremes outliers with a very long run that still maintains good score. Correct? Is a good score passively representing a special features or epic narratives. In terms of additional insights, I'm going to talk about the score variations. So, in terms of I'm talking the score variations, it's both type exhibits a wide range of scores. However, the peaks in a certain runtime bands may reflect success performance or popular content types. Other things is the shorter shows with high range may indicate the popular series episode or contents catering to niche audiences. In terms of the viewer engagement, the clustering of high IMDb scores across varying runtimes is that the quality contents engage viewers regardless of the length. Another one is longer movies with a good rating as might reflect the strong narratives or blockbuster types contents appealing to audiences. In conclusion, I'm going to talk about the relations between them. In the relations between runtime and IMDb scores at Netflix is complex and influenced by the content type. And second is highly quality storytelling or production seems to trump runtime's length in determining scores. For both movie and shows, is the balanced runtime that meets genre and audience expectations is likely key to higher range. The claw, I'll be right back. See you next video.